Alrighty gang, welcome aboard. It's nearly holiday time. Of course, being on the internet, that all depends on when you're viewing this. But for me, it's 9:30 at night. I had to crack through some of these financial and regression-based questions in our lead up to exam time. Happy days. Okay, so let's get stuck into it. The value of a photocopier is depreciating. Let's grab that. Is depreciated using a unit cost method. Okay, unit cost means it's every time it's used, it drops a certain amount of cost, same amount of cost each time. Okay, and that in that statement in particular is the key. So let's first off take a look at what we've got. Which one of the following graphs could show the value of the photocopier over time? Alrighty, we know that the photocopier is depreciating, so let's get rid of that and that and that straight away. Okay, and last of all, we need to ask ourselves how well we know unit cost method. So if it's worth something up here and it prints one page, and every page it prints it loses $1, so here it loses $1, it drops that much. Here it loses another $1 after it prints 2 pages, loses another $1 after 3 pages, and so on. We have a dead straight line. Okay, so we want to say our answer is going to be A there. This one is not losing the same amount each time. Simple as that. Depreciating, dropping in value, unit cost, dropping by the same amount for each unit, whatever that might be, is worth. Okay, might be every page, every 1,000 pages, etc. Alrighty. Next one, an amount of money is deposited into an account that earns compound interest. Okay, that's my highlighter. So compound interest, which combination of interest rate and compounding period has the largest effective interest rate? Okay, keywords being effective interest rate. We should instantly trigger that function is available on our calculator in one of the financial settings. So first off though, we want to save some time and not go through each one of these calculating the effective interest rate. Okay, first things we know is that if we have 3% being applied compounding quarterly, the same percent compounding monthly or more often will be better than quarterly, and again weekly will be better than monthly. So we know it's not going to be B, it's not going to be C. Alright, we're interested in A. Here we've got 3.8% twice. Once is compounded quarterly and the other monthly. Now if something is compounding more often but at the same rate as another compounding term or period, then the more often something compounds, the better. Okay, so we are also not interested in E. Alright, that leaves us only 2 to check. Alright, saving us a bit of time. So let's jump out over to our CAS, go up to Actions, Financial, Interest Conversion, Convert Effective. We're after the effective interest rate, or what the actual interest rate would be per annum. In that, we want to put in the periods first. Okay, so compounding periods per year. In the first one, we have monthly, so that's 12. And then after that, we need to put in the nominal rate, which is 3.8. And it'll just be good and close our bracket. Okay, so that one comes to 3.867. Okay, that'll be kept there anyway. And secondly, we want to do the same thing. We could always copy that, bring it down. And we have this time a weekly, so compounding periods per year is 52, and then we have a rate of 3.7%, and we get 3.76. Okay, for that one, let's bang that in blue. So 3.76. Let's round it out to 77. Okay, we can see that that is the better rate, 3.867%. That hasn't even cracked the 3.8%. So our answer is D. Okay, key there is to jump onto your CAS pretty quickly. You can see that they're close. It's not worth working out manually. There's no extra points for that. Okay, cruising on down. This one, Rosalind invested some money in a savings account that earns compounding interest compounding annually. The interest rate is calculated and paid at the end of each year. Okay, so just reiterating that. Let VN be the amount of money in Rosalind's savings account in dollars after n years. The recursion calculations below. So they've done the recursion calculations. They haven't necessarily given us a recursion rule, but they've shown that after 2 years, Rosalind has $5,512.50. How much money did Rosalind initially invest? Okay, this is just about being able to read a recursion equation. Okay, we want to know that a V0 is the initial investment or the starting amount in any financial question. Okay, so the initial amount that Rosalind invested was $5,000. Okay, make sure we have a dollar sign, or you write dollars after it if you don't have a dollar sign. Make sure you get the units there. How much interest in total did she earn by the end of the second year? Okay, so we want to check what the balance. So interest is the balance subtract the original investment. Okay, so Rosalind has a balance of $5,512.50, and the initial investment was $5,000. So the difference between the two, because she hasn't added to the investment, the difference between the two is going to be how much interest she's made. So 512.50. So the interest is equal to $512.50. Okay, pen's a bit glitchy at the moment for some reason, and that's that one there. Let's cruise on across to this question here. Let VN be the amount of money in Rosalind's savings account in dollars after n years. Write down the recurrence relation in terms of V0, VN plus 1, and VN that can be used to model the amount of money in dollars in Rosalind's savings account. Okay, so we're just asked to write the recurrence relation for this one. Okay, so we can start with V0. Okay, we know that the initial amount was $5,000. Okay, comma, and then VN plus 1 is equal to, so that's equal to 1.05 times VN. Okay. So we've got it in terms of, we've got V0, VN plus 1, and VN. So if we were to replace VN with the first, with the initial term V0, that would give us V1. Then replace VN with V1, that would give us V2, and so on. Okay. Alrighty. Next, cab off the rank. The community centre opened a savings account with Bank P. Who cares? Let PN be the balance of the savings account after n years after it was opened. The value of PN can be determined using the current relation below. Okay, we've got that all there. The balance of the savings account 1 year after it was opened was 1,584. Show that the value of A is $1,500. Okay, so one way we can do this is, and probably the best way, is to let, so PN plus 1 is the result of whatever we are calculating recursively. So if we have 1584 was what we had, and that is equal to 1.056 times PN. Okay, if we divide both of those by 1.056 to get PN on its own, then that will give us hopefully 1500. So I'll jump over to our CAS, go 1584 divided by 1.056, and there we have it. Better write that in just for good measure. 1.056, 1.056, so they cancel each other out, and when we divide that we get 1500 is equal to PN, which if this is originally, if that was going to be P0 originally, that's what it would be. Write down the balance of the savings account 4 years after it was opened. Okay, so we can either do that. I mean, it might be easiest with the information we've got there, just to do it recursively. So we want to punch in 1500, 1500, and then we want to go 1.056 times that answer. And then we go, that's 1 year, 2 years, 3 years, 4 years. Okay, so write it down. So it's 1,865 and 29 cents. Put that dollar sign in there. Okay, for this next one, we will have a look what we've got going on for part C of this question. So the balance of the savings account, which was 2,085 cents, was transferred to another bank, Bank Q. Pays a rate of 5.52, which compounds monthly. Okay, let QM be the balance of this savings account in months after it was opened. Complete the rule by writing the missing values. Alrighty, so our rule, let's kick it off. Now, we should be familiar that the nth rule, the nth term equation is Vn, Qn, doesn't matter what it is equal to, so you might be familiar with Vn is equal to R to the power of n times V0. Now this one we have to be careful because the power of n is on the right hand side this time, so it just means we put R over here. Okay, we don't put V there, V0 or anything like that there, doesn't change it. This pen is driving me nuts today. And in this one we have our 0, which is in this case Q0. Alrighty, so we can put that in straight away. We know that that's equal to $2,080 and 5 cents. Okay. For our R value though, hopefully we remember that because we're gaining interest, it's a 1 plus, and then the rate divided by the number of terms. So here it'll be divided by 12 because it's monthly over 100. Okay, I'll punch that in over in the CAS. We get 5.52 divided by 12, and then divide that by 100. And that gives us 1 plus 0.0046, okay, which is equal to 1.0046, okay, and there's our answer. Okay, rock on down. And that is it, okay. Hopefully that is helpful. There are, if you're on my OneNote Teams page, etc., doing this course, then down below here, scroll down, are your questions for Chapter 8. Good luck with them. Check out the VCAA examiner's guides and their solutions for anything you might have trouble with, and if not, get in contact. Have a great holiday. Hey, you could be watching this in the middle of term sometime, so sucks to be you. But have a good time, and we will see you soon. Ciao.